me give you the rundown of what we have this week. So, looking in Buzz, Foundations of Programming. If we go to our grade screen, we see we're done with Module 1. Yesterday, Module 2 was due. See, I didn't turn it in until today. I was feeling sick last week. Didn't get my work done. That's why it's red. It's in red because I turned it in late. But it's turned in. And this week is 2.02. So 2.03. Next week, we have fall break. We will not have classes Mondays, Tuesdays, and Wednesdays. So we have Thursday and Friday, and we do not have any mandatory class. It's your break. No mandatory class next week. But Friday will be an A day this week and next week. So next week, all you'll have is Thursday and Friday, and it's a B day and an A day. So if you need help, you can come to class and check in with me on Friday. But otherwise, you have a week free with no classes. But next week, you'll have the math module. And that is something you have to submit. A program you would write, you would submit, turn in. So let me talk about that real quick. When you submit, let's go back to activities. When you submit a document, see right here, that's what I've done. I take the code, this is my actual code, and I copy and paste the code in here, or I create a Google document. If you want to keep your code, make a Google document of it, put everything in the Google Doc, and then you can just choose Google document to attach. And that's fine too, as long as you remember to give me permission to view it. You can create a Google document, but I do not want a screenshot of your output, of your code. I do not want a screenshot of your code. You can give me a screenshot of your output if you want to, not necessary, because I'll have your code right here. Because I take your code and I will copy and paste it in and see if it runs. Right? If you do just a screenshot of it, then I can't do that. I have to type it in. And if I make an error, I'm going to count as your error because I just typed in your code. You do not do screenshots of your code. So I've just showed an example. If I could just take it and paste it in here. I also would have to paste, if it asks for pseudocode, I'd have to paste the pseudocode in here. Those postmortem review questions, I'd have to paste those. If you're gonna put it in here, put everything in here, everything that it asks for. Your pseudocode, your code, and your postmortem review. All right. And of course, the assignment is going to be, yes, I want to leave that. The assignment's going to be at the end of the lesson when you have those. So if I go to page 5, see right here, here's the assignment. You can just go down here and save, and it will make a Google Doc for you with all of this information. Then you can insert your pseudocode right after here, paste it in there, paste your copy of your Python code in here, and then answer your 3 questions right, or your 4 questions, I'm sorry, 4 questions right there. But here is the instructions of what you're supposed to do, including writing the pseudocode first. That's your plan. So while we're talking about that, if you go here, I do have a pseudocode in our Google Classroom to just help you. You're basically just writing in English. Say, I'm going to display this. I'm going to input this. I'm going to put it in this variable. But this is just something we have put together at the computer science department here, that if I want to assign a variable, something to A, if I want this expression to be part of A, I can just do A with an arrow and say, whatever this expression is, I'm going to assign it to the variable A. Right? And if I want to print something, I'm going to say in my pseudocode, I'm going to display this on the screen, display whatever this expression is, right? So this has lots of things. If I'm going to input something, input whatever. I don't have to put all the proper quotes and colons and all kind of stuff, not in pseudocode, because this is just writing the plan in more of a plain English format. This is not an actual code that would run in any language, right? So if I just want to do an A plus B thing, do some math of some sort, there's all kinds of, as we get through the semester, we'll use more and more of these, things. But this is right here in Google Classroom if you need some help writing pseudocode. But it's really just a code plan in English, what you're going to do, pseudocode. So I'll be more generous with that. the code has to be exactly correct. So, all right. So that's what is coming up for next week. Next week, you have to write a program again. So I just wanted to go over that real quick. Let's go over the lesson for this week while we're here, getting numeric input. So there's important things to know when you're using numbers. Shakespeare said, what's it a name? Well, the literal answer, that's letters. Letters are in your name, unless you're Prince, who had a number in his name for a while. Great question. There's a bunch of letters. But there's lots of other equally significant questions, like how many Oreos are left over. A lot of people don't understand that question. What's a leftover Oreo? Or what's my age in dog years? Right. So you can write a Python program to calculate these things. So let's look at what Python's telling us this week. All right. As you know, there's a difference between these three data types. So let's see for ourselves. String. A string is a value composed of letters or numbers that are not to be used for math. They're just like using it like a phone number here, 800-374-1430. That's a string. You can't calculate anything with that. A float or an integer. That's the two types of numbers we're going to use in programming. We use a float number or an integer number. And the difference is floating point. A float number is a numeric value that contains a decimal. It can be either a positive number or a negative number. Doesn't matter. 0.01, negative 1.3, 0.0. See, while it has the same value as 0, this is a float representation, floating point representation of 0, where this over here is an integer. Integers do not have decimals. It's like the counting numbers, the normal numbers used are integers, and it can be positive or negative. Like the value of pi is definitely a floating point because it's 3.1415. The number of cookies you just ate, we don't say you ate 2.68 cookies, so you ate 3 cookies or you ate 2 cookies. So here's what it means in programming. For a string value, the memory space depends on how long your string is. The longer your string, the more memory it takes up, the more characters that are there. For floating point numbers with decimals, that uses a higher amount of memory. And it's important in programming. Don't waste all your memory. Floats are more precise because they have decimals. 2.86 is more precise than saying it's about 3. So 3 is just a rounded number. 2.86 is much more precise. And sometimes you need to be precise in your calculations, and you use a float, but it will take more memory space. Integers are low memory space. It's just storing just the integer. All right, so you got to keep in mind which one of those you're using when you do something. Am I going to do math? If I'm not going to do math, it could just be a string. That number can just be a string if I'm not going to do any math with it. But otherwise, if I'm going to do math with it, I need to know whether to assign it as a float or as an integer, right? So here's some samples for us to test. Do we know the difference? The total number of books in the Harry Potter series. Well, we know that's a number. Total number of books is a number, but it does have a decimal. Are there 11.6 books in the Harry Potter series? No, there's not 11.6. It's an integer. It's a common counting number. Number of steps I walked today. That's going to be an integer, right? You walked 6,412. You didn't walk 6,412.78 of a step. You didn't get to count another step or instead. Social Security number. Social Security number has like 123 dash 45 dash. So that means there's string values. We're not going to use it for mathematical purposes. We're not going to multiply your Social Security number by your age or nothing crazy like that. P. Sherman 42 Wallaby Way. Well, it has an integer in it, but the whole thing is just a string value. Points our basketball team scored. Well, they didn't score 38.5 points. They made it an integer, so it's going to be always a common counting number. But the number 8, there's no decimal. But the cost of an ice cream cone, That may cost you $2.59. That's a decimal in there. It's going to be a float. This one has a decimal right in the number, 8.342. Your telephone number, again, it's going to have dashes in there. You're not going to do any calculations. Hello world. That's a literal string right there. You can see it's letters. The results on a stopwatch, that's always going to have some decimals in there. It's precise, usually to the thousandth or 10,000th or something. Number of liters in a gallon. Well, it's not 2, it's not 3, it's not a nice even number. It's going to be something with a decimal. So you can run through those and practice yourself, but that's how those turn out. And it'll tell you anytime you're wrong with any of those. So now we need to know when to integer and when to float. All right. Say you got a part-time job and you make $9 an hour. Python can help you figure out your pay. You can write a program and keep this program and just run it over and over again every week to see how much money you earned. This is where the input function can be really useful. All right. Now, by default, Python assumes that anything you enter for input is a string. It's a string, which means you can't do math with it unless you tell Python this is not a string. So let's look at this example. So here's a program they wrote. Hours equal. So they assigned the variable hours, HRS, whatever the user inputs when it says enter hours. And here's the rate. So to the variable rate, they assigned a value of 9.00, which is they make $9 an hour. So the pay for that week will be the hours times the rate. So print what my pay is. All right, so she wrote the program. Jenny worked from noon to 6. So she put 6 hours on her timesheet. And she should come and run her program. She says, enter the hours 6. What's going to happen here? Well, what happens, you get an error. It cannot multiply the sequence by a non-integer of type float on line 3. When it tried to multiply hours times rate was this floating number, but the input, remember, it defaults to a string value. It says, I don't know how to multiply a string value. Even though she inputs 6, it's counting 6 as a string value. So it doesn't know how to multiply a string value times 9. So here's how she's going to fix that. In front of the input, integer, parentheses, everything that's inside this parentheses, I want you to treat it like an integer now, like a whole number. So when you input your hours, enter hours of 6, it says, okay, now I know I can treat that as an integer, and 6 times 9 is 54.0, because you have a float number here for rate. Since that's a float, it's going to include the decimal, 0.0. So you earned $54. Well, what about the next time when her buddy Sheldon works, and he worked from noon to 6:15, and he said, oh, let me use your program. So he worked 6.25 hours. So he comes over, runs the program, and enters 6.25. Well, there's going to be a problem because we told it it's an integer. And it says, oh, there's an invalid literal for integer. Because 6.25 is not an integer. It has a decimal value in it. So then we can change it to say, okay, we'll make it a float number instead. And you could always leave it as a float, because even if you just entered 6 without a decimal, that's fine. It'll take that as a float, 56.25. All right, so that's when you use the integer and the float commands, is when you want to change what someone's inputting from a string to a number that you need to use to calculate. Let's look at this last page here. So they converted their to integer and float, and this will break it down for you. Age is the variable. Equal. This tells that you want to assign something to your variable. Whatever's after this equal sign, so I want to make this variable. Integer. This is the function integer that tells Python to treat this information like it's an integer. There's the input statement that tells Python to ask the user, what year were you born? Okay. For float, GPA is the variable. Equal. Float tells it to treat it as a decimal, as a number that we can use in math. And then here's the input statement. What is your GPA? All right. So here is another activity. I'm not going to go through this. This is for you to get in there and see if you can do this correctly. There's 3 steps. Here's number 1. Read the code, predict the output. Read this. There is a runtime error, it tells you. And I want you to run it and use the input of 3 and see if you can figure out the error on that. And after that, read the code again, try to predict again. Use 5 and $19.99 for the cost. And then there's a logic error. See if you can fix the logic error there. And then the last one, let's add a $5.50 off coupon. So they want you got to add some code that asks the user for the value of the coupon and then calculate the new cost after they tell you that. All right, so there's your practice right there. That's where you practice. And then you get to the end and it says, okay, practice using Python, and then do the next assignment that goes with this lesson. And there it is. It's 5 multiple choice questions this week. All right, 5 multiple choice questions. Again, next week you have some more code to write. No class on Wednesday, but make sure that you are coming and getting help if you need it next Friday, because this Friday and next Friday are A days. So I will be here having class on Friday if you need some help. But otherwise, enjoy your fall break, guys. Get your work caught up to where you can actually take several days off and just relax, enjoy yourself, and enjoy your break. So we will see you in 2 weeks, unless you need help, or if your grade's below 70%, get your stuff turned in. We'll see ya.